Hey guys, it's Miss Farron here, and we're going to look at Unit 8, Notes 4, Rationalizing the Denominator. So our learning target for today is I can simplify radical expressions involving division and then rationalize the denominator. So the simplified form of a radical expression, we've kind of talked about this before. It has no perfect squares under the radical, no fractions under the radical, and no radicals in the denominator. So we're going to go ahead and we're going to focus on these two things today, the fractions and the radicals in the denominator. In order to do that, we really need to remember our quotient property here. And what that says is if I take the square root of a divided by b, that's the same thing as taking the square root of a divided by the square root of b. So we're going to use this quotient property a lot here. So let's look at example number 1 here. I have the square root of 15 divided by 12. Now this is not simplified for us because we have a fraction under the radical. So the first thing I want to look at is, can I reduce the fraction? Can I take anything out of 15 and 12? Well, I know that I can take a 3 out of both things. So I'm going to simplify this by dividing this thing by 3, each of them by 3. So 15 divided by 3 is going to give me 5, and then 12 divided by 3 is going to give me 4. Now that that fraction is simplified, we can go ahead and we can use the quotient property that says I can take the square root of the top divided by the square root of the bottom. We don't like having radicals in the denominator. That's another problem we have. We cannot have radicals in the denominator if we're in simplified form. So we're going to go ahead and try to take the square root of that thing in the denominator. Well, I can actually take the square root of 4. I know that that's going to be 2. And then the square root of 5 is a decimal, so we're just going to leave that as the square root of 5. This, then, is in simplified form. I don't have any fractions under the radical, I don't have any radicals in the denominator, and there's no perfect squares under radicals. Number 2, we're going to do the same idea here. So I'm going to go ahead and I'm going to try to simplify 21 and 27. Again, I know that the 3 goes into both of them, so I'm going to divide both of them by 3. So I'm going to end up with the square root of 7 divided by 9. Now we're going to use our quotient property, so I'm going to take the square root of 7 divided by the square root of 9. If I do that, I know that the square root of 9 is going to be 3, and the square root of 7 is a decimal, so we're just going to leave that as the square root of 7. So what if we have something where I cannot take the square root of the bottom number, where it is a decimal? Then we need to do what we call rationalizing the denominator. So when you have a radical left in the denominator, you have to rationalize it. And here's how we do that. We simplify the radical expression. Then we multiply the top and bottom of the fraction by the radical in the denominator. And then we simplify. So this is going to be really important for us to remember. You can never leave a radical in your denominator. And if you have one there that you can't take the actual square root of, then you have to rationalize it. So let's look at number 3 here. I'm still going to go ahead and do the same steps I did before. I'm going to try to simplify the fraction underneath the radical. Well, I have 1/3. I cannot simplify that at all. So now I'm going to use the quotient property, which tells me I can take the square root of the top divided by the square root of the bottom. I would try to then take the square root of 3, but if I do that, it's going to give me a decimal. So this is where we have to rationalize this. How do I get rid of that square root of 3? Well, we know that we need 2 of these. We need this thing to be squared. So I need to multiply this by the square root of 3. What you do to the bottom, you also have to do to the top. So now, using our properties of multiplication, we know that we multiply the things in front and we multiply the things underneath. So the top is now going to be the square root of 3, and the bottom is actually going to be the square root of 9. To get rid of that denominator now, I can actually take the square root of 9. I'm going to end up getting 3 on the bottom, and the square root of 3 stays on the top. Looking at example number 4 here, again, we're going to go through our steps. We want to simplify the fraction underneath. Well, I know that a 2 can go into both of these, so I'm going to divide them both by 2. So I'm going to end up with the square root of 6 divided by 5. Now, the quotient property tells me I can rewrite that as the square root of 6 divided by the square root of 5. We don't like that, and I'm actually going to bring that down here so we can play with that. So I have the square root of 6 divided by the square root of 5. I want to try to take the square root of 5 because we don't like that radical in the denominator, but I can't because that's a decimal. So to rationalize this, we're going to multiply by the square root of 5. What we do to the bottom, we also have to do the top. So then I'm going to end up with the square root of 30 divided by the square root of 25. So I know that the square root of 25 then is going to be 5, and the square root of 30 I cannot simplify any further, so I'm going to leave it as that, and that would be my final answer. So number 5 here now, I want to go through my steps. Can I simplify the fraction first? In this situation, I cannot, so now I'm going to rewrite it as a quotient property. So I have the square root of 10 divided by the square root of 3. I cannot take the square root of 3 on the denominator, so we're going to rationalize that by multiplying it by the square root of 3. What you do to the bottom, you got to do the top. So I'm going to end up with the square root of 30 divided by the square root of 9. I can now take the square root of 9, so I'm going to get 3. And again, the square root of 30 cannot be simplified, so that's going to be my final answer. Example number 6 here then. We could go ahead and simplify this if we wanted to, but I actually see something right now. If I go ahead and I take the square root of the denominator as is, then I actually would skip a step. I wouldn't have to rationalize anything. So I'm going to rewrite this as the square root of 6 divided by the square root of 9, which is going to give me 3, and the square root of 6 cannot be simplified, so that would be my final answer. So looking at number 7 here, we want to go ahead and follow our steps just like we've been doing. We want to try to simplify the fraction under the radical. So I can divide both of these things by 3. So I'm going to divide this by 3. I'm going to be left with the square root of 9 divided by 5. So now I'm going to go ahead and write that using the quotient property. So I'm going to do the square root of 9 divided by the square root of 5. I cannot take the square root of 5 in the denominator, so we're going to rationalize this by multiplying by the square root of 5. What you do to the bottom, do to the top. So in the denominator, I'm going to have the square root of 25. Now, usually you would multiply 9 times 5, but I see that I can actually take the square root of 9 right away. So I'm going to do that. Square root of 9 is going to give me 3, and then I'm still going to multiply that by the square root of 5. One extra step further then, square root of 25 is 5, and I still have 3 root 5. I would try to simplify this if I could, but 3 and 5 can't be simplified, and the square root of 5 can't be simplified, so that would be my final answer. So now number 8, we want to go ahead and simplify the fraction underneath if we can. We cannot in this situation, so I'm just going to go ahead and rewrite this as a quotient property, or using the quotient property. So I'm going to have the square root of 5 divided by the square root of 12. Then we need to rationalize the denominator by dividing or multiplying by the square root of 12 on top and on bottom. So I'm going to end up with the square root of 144 on the bottom and the square root of 60 on the top. So the square root of 144 I know is 12, and then the square root of 60 can be simplified. So we're going to do that work over here. I'm going to do the 60 and I'm going to prime factor it. So I'm going to get 2 and 30, 2 and 15, 3 and 5. So these would be a pair that I could bring out front of the radical. And then the 3 and 5 would stay underneath. So I would leave that as 15. Last step then is simplifying. I can simplify 2 divided by 12. So I know that a 2 goes into both of them. So I'm still going to have the square root of 15. And then 2 goes into 12 6 times. This would be my final answer then. So for number 9 and 10, I want you to pause the video, try them on your own, and then come back and check your work. Remember your steps. So here are my answers of what I got when I went through and did 9 and 10. If you got anything different, please come check in with me before moving on for the rest of the video. So for example number 11 and 12, it's the same idea. We just have variables going in the denominator now, so we're still going to follow those same steps that we've been following the entire time. We want to see if we can simplify the fraction inside. For number 11, I cannot, so I'm going to write this using the quotient property, telling me the square root of 3 divided by the square root of 8x to the third. So now we need to rationalize the denominator, so we're going to multiply by 8x to the third by 8x to the third. So this is going to end up giving me 24x to the third, the square root of 24x to the third on top, and the square root of 64x to the sixth on bottom. So on the denominator, I know the square root of 64 is 8, and then the square root of x to the sixth, think of that as I have x times x times x times x times x times x, and they need pairs to come out. So I have 3 pairs, so it would be x to the third. So I'm going to do the same kind of idea with the top now. The square root of 24, I know that I can break that up into be the square root of 4. So this can be written as the square root of 4 and the square root of 6, and then the square root of x times x times x. So I know that these pair is going to come out front, and I can take the square root of 4. So I'm going to be left with 2x on top, and then the square root of still have a 6x underneath. So our last step now is to simplify. I can simplify the 2 and the 8. A 2 goes into both of them. So 2 goes into 2 once, 2 goes into 8 4 times, so I'm going to have 4 on the bottom. X divided by x to the third. Remember, we do the bigger number minus the smaller number, and it goes where the bigger number is. So I would have an x squared on the bottom, and then I still have the square root of 6x on top. I can't simplify that anymore, so that is my final answer, and I would be done. Number 12 then is the same kind of idea. We're going to go ahead and we are going to use our quotient rule, and we're going to divide or split it up. So I have the square root of 7 divided by the square root of 18x to the fifth. So I need to rationalize that, so I'm going to multiply by 18x to the fifth. What I do to the bottom, I do to the top. So I'm going to end up getting the square root of 126x to the fifth on top. And then if you haven't seen the pattern yet, the bottom I'm just going to end up with the thing that's underneath the radical by itself. So I'd have 18x to the fifth on the bottom. So now we have to simplify the top. So I can rewrite the top as the square root of 9. I'm looking for that perfect square, and 9 was my 1, times the square root of 14. And then x to the fifth is x times x times x times x times x. And that's still over 18x to the fifth. So now these are pairs. They can come out. So the square root of 9 is 3. I have 2 x's that are coming out, so I have x squared. And then I still have the root of 14x divided by 18x to the fifth. Last step is to simplify then. 3 goes into both 3 and 18. So in the denominator, I'd be left with 6. Dividing, we subtract the exponents, so we do bigger minus smaller. So 5 minus 2 is 3, and it goes where the bigger one was. So I have x to the third on the bottom. And then I still have the square root of 14x. So our last example here, number 13, the period of a pendulum is the time required for it to make one complete swing back and forth. The formula of the period P of a pendulum is P equals 2 pi times the square root of L divided by 32, where L is the length of the pendulum in feet. If a pendulum in a clock tower is 6 feet, find the period. So we're going to use this formula, and we're just going to plug in 6 feet for my length. So I have the square root of 6 divided by 32. So we're going to go ahead and simplify that. I know that I can divide this thing by a 2. So I'm going to divide everything underneath the radical by a 2. So I'm going to get 2 pi is going to equal 3 over 16. So now using our quotient property, I'm still going to have that 2 pi out front, but I'm going to rewrite it as the square root of 3 divided by the square root of 16. And I can actually take the square root of 16. So I'm going to get 2 pi times the square root of 3 divided by 4 for the square root of 16. So now remember, just like when we had x's, this 2 pi can be written on the top of that fraction. So I'm going to go ahead and write it as 2 pi square root of 3 divided by 4, and now I'm just going to simplify. So 2 goes into 2 once, so I'm left with a pi square root of 3. 2 goes into 2 twice, or 2 goes into 4 twice. And now to give this would be a good answer, or you can give it as a decimal. So if I were to plug that into my calculator, pi times the square root of 3 divided by 2 would be about 2.72 seconds. So either answer would be correct for me. Practice is your next step. If you have any questions, come chat with me.